If you're creating a great new app or application, there's a good chance that you want to make it a product or part of a production process. For a normal software application, that would mean implementing some DevOps. But if you're using machine learning, then what you need is MLOps. In this talk, I'll try to explain the difference and how you can put together an MLOps solution and why TFX is such a great choice. Let's start with the basics. Why do you need MLOps? Well, there are two big reasons why you need MLOps, and in a nutshell, we can call them process and change. Let's start by looking at process. When you're developing a product, you need a production-level process and infrastructure. And the world is even more complicated with production ML, where you're not just working with code, you're usually working with ever-changing data. At Google, we've measured the ML model code to be something like 5% of the total code necessary to train and deploy a model in production. All of the other tools and infrastructure that you see here are critical to the success of your product or service. We can't go into detail on all of them, so we'll just look at the highlights. Why do you need all of that? Well, first, we know that we have all of the requirements of any machine learning application, which includes things like getting labeled data to train the model, making sure that it covers the feature space, minimizing dimensionality while maximizing the predictive information in the data, and then other considerations like fairness and rare conditions, especially in fields like healthcare. But we also need to think about the life cycle of the data. How long is it still valid? And whether it contains sensitive information. And, along with all of that, we're putting a piece of software into production, so we need all of the things that any production software deployment needs. Can we scale? Is it extensible? Is the behavior consistent and reproducible? Have we followed industry best practices? Have we written the code to be testable and implemented CI? Do we have monitoring? Have we considered safety and security? This part is very similar to traditional DevOps, but with the added twist of data being a first-class citizen. It's not just code. So yeah, that's a lot, especially if you're trying to build it all yourself. But don't worry, you're about to find out how to make it easier. The bottom line here is that if you're creating a product, you need a production-level process. You need MLOps. Now let's turn to the other big reason that you need MLOps, which is change. Let's start with a thought experiment. Imagine that you're a retailer selling bicycles. Like any retailer, you want to optimize your inventory. So you train a model using data from your app to predict demand. That's a great idea. And at first, it's going great. You're ordering just the right amount of each type of bicycle, and your business is thriving. But then, slowly at first, you start making mistakes in your ordering. It takes you a while to notice, and then you realize that you either have too many bicycles, or not enough, or the wrong type of bicycles. Not good. But why? Your model was doing great. So why did it start getting the forecast wrong? And now that you know that you have a problem, how do you fix it? And maybe more importantly, how could you have been alerted to the problem before it got so bad? Well, fundamentally, the reason that you have a problem is that the world changes. That means that in order to adapt, your model needs to change too, which means that you need to constantly gather new data and retrain your model on the current reality. That means that you need systems and a process in place to do that. You need MLOps. So to develop a product that uses ML, you need to implement a production process and design for change. You need MLOps. So now you might be wondering, how can I implement an MLOps infrastructure? Well, let me tell you. Let's step back for a moment and look at all of the major components that make up an entire MLOps deployment and think about where TFX fits. We can't go into a lot of detail, so we're only going to look at the big pieces here. The primary use of TFX is to create training pipelines to train models in a robust, repeatable, and automated fashion. Although I should also mention that TFX can also be used to implement a prediction pipeline for batch inference. A major advantage of TFX is that it scales very easily from running on a single laptop to a large compute cluster with almost no code changes. More about that in a second. TFX also includes ML metadata, which captures all of the results of each step in your pipeline, all the way from the initial dataset to the final trained model. That's incredibly powerful, and it allows you to understand your model and data over the lifetime of your product, so you can make comparisons and understand changes in performance and metrics. More about this in a second. TFX deploys trained models automatically to one or more types of model serving, including both TensorFlow serving and vertex prediction. TFX also trains and deploys models for use in mobile applications using TF Lite or web browsers using TFJS. In order to develop models, you'll also need a framework for experimentation. The libraries that come with TFX can really help here, especially when you're working with large data sets. TensorFlow data validation, model analysis, and transform can each be used on their own to analyze your data and model performance and perform feature engineering. It's also a great idea to do your experiments in a TFX pipeline, which makes deployment to production as fast and easy as possible. And of course, you'll also need a feature store. Both the Vertex feature store and the open source Feast feature store are great choices here, and Feast is supported for TFX by a community-contributed component through TFX add-ons. Did I mention that TFX is open source? Well, it is. And the ML community is busy building new components and libraries to add to TFX. So, to create an MLOps solution, a production ML process, and manage change, a great place to start is with TFX. At Google, we have exactly the same problems that you have. We needed software, systems, and a process to implement an MLOps solution for the many products and services at Google that use machine learning to deliver amazing things. So our research team studied the problem, learned from experience, and created TFX. A lot of that experience is summarized in a recent paper that reviews the ML engineering journey at Google from the early days up to today. TFX has been shaped by the lessons learned over many years of experience with putting ML in production in very demanding environments. When you install TFX, this is what a typical first pipeline looks like. I call this the hello world of TFX. Those things in orange and green are called components. The components in orange are the standard components that you start with for model training, and the ones in green are a pipeline for batch inference. TFX comes with a great set of standard components to get you started, and you can create your own custom components. In a training pipeline like the one in orange, you train your model and deploy it automatically to one or more serving environments, including TF Lite for mobile apps and TFJS for web apps. Let's take a quick look at how TFX components work. First, think of each component as performing some task. For example, a component called ExampleGen ingests your data into your pipeline, and another component called Trainer trains your model. Along the way, the inputs and outputs for each component are referred to as artifacts. The TFX metadata store, ML metadata, captures and manages all of the artifacts that all of your components create during the lifetime of your product. That gives you the ability to go back and do comparisons over time as your data, model, and results change. So, as data flows through your pipeline, artifacts flow from upstream components to downstream components through the metadata store. As you might expect, TFX is used in many Google products, including services provided by Google Cloud and also by other companies in the Alphabet portfolio. It's also used by many other companies that you've probably heard of, and many more that you may not have heard of. In fact, there have been well over 10 million downloads of TFX, and chances are pretty good that you have used something today that used TFX. As I mentioned earlier, you can run TFX just about anywhere. For example, you can run it in a notebook without installing anything by running it in a Colab. All you need is a web browser. You can also run it on your laptop, which I do a lot as I'm developing pipelines. And you can also run it in the cloud, either in Vertex AI pipelines or just on GKE, or even in a VM. And you can also run it in a containerized environment using Kubeflow. As I said, you can run it just about anywhere, and that flexibility is incredibly powerful. It's also flexible in terms of the types of models you can train. Of course, we all know and love TensorFlow, but you can also use TFX to train models for scikit-learn, XGBoost, JAX, PyTorch, or whatever. It doesn't even have to be Python, because you can run TFX components in Docker containers. So now you might be wondering, how can I learn more about TFX? Well, let me tell you. First, please visit our website, which is tensorflow.org/TFX. There's a lot of great stuff there to get you started, including tutorials, our user guide, and our API reference docs. You can also sign up for a 4-course specialization that we've created with Andrew Ng at Coursera, working with deeplearning.ai. It covers TFX and a whole lot more to help you come up to speed on the state-of-the-art for production ML. And remember, TFX is an open source project, so you can contribute too. One of the best ways to get started is to join our special interest group, TFX Add-ons, which brings together community contributors to create new components, tools, libraries, examples, and visualizations to make TFX even better. You can continue the conversation with me and the rest of the TensorFlow community in the TensorFlow forum. It's a place for our developers and contributors to engage with each other and with the TensorFlow team. Head to discuss.tensorflow.org and create your account today. To wrap up, the bottom line is, when you're ready to make your app a product or service, don't reinvent the wheel. Use TFX and go from zero to hero with production ML. And when your app rocks the world, please let us know by posting in the forum or write a blog post about your adventures and send it to us, and we might even post it in the TensorFlow blog. So, that's my talk. Thanks for listening.